Hello, everybody. Welcome back. Late Start Edition, Section 6.1, Homework Review, featuring Mr. Laverick and company.
Hey, everybody. Thanks for the intro. You know, it's funny. I was looking back at my YouTube channel, and like I get 0 views on all of these comments. I mean, because a lot of you guys are here all the time, so it's like they're not going to waste, but they're just going unappreciated. They're going unappreciated.
Has that kid ever commented back?
No, I haven't. Shout out, Jerry, if you're watching. Shout out. I have 112. I mean, that's pretty good, in my opinion.
0 views though.
Right. My page doesn't get much traffic. Pretty close. I'm expecting the email very soon. All right, so what questions do we have? 3? I heard 3 right after that. Okay. Let's take a look here at question number 3. Okay.
Way down yonder on the bed.
Let's not start that again, please.
Yeah.
All right. Okay, first thing that I want to do here is take a look and see if I want to integrate over y or x. Right? This is showing me that since I've got a boundary line for my y, it'd be easier if I do this and perform the integration over the y values. Now, there's been a lot of talk about, okay, well, how do you know, what's my lower boundary with my upper boundary? Remember that you're just going to go in order, because again, if you needed to, if you were wondering, you could always just take the absolute value, right? If you did it the other way, it would just come out negative, so you just take the absolute value. Because this is really equivalent, to the absolute value of this is really the equivalent to this, right? Well, I put it the other way. Right, those two things are the same, right? So I'm just going to do this. -1 to +1. Smaller on the bottom, bigger on the top. And then we go top minus bottom. Top minus bottom. Now, what's on top? E to the y. What's on the bottom? Y squared minus 2. I don't want to worry about the fact that they're solved for x. That's a good thing that they're solved for x. Because, normally I'd be looking at equations that are like y equals a number. And if that's the case, I'm going to integrate over x through x, not y. So I want them solved for x. I want the equations where x equals the rest of the function. All right, so now we're distribute the negative. I forgot dy. Whatever. So we have, this is -1 to 1, e to the y minus y squared plus 2 dy. And now I find the antiderivative, which means that's e to the y minus y to the third over 3 plus 2y from -1 and 1. Just double check my answers here. My number 3, e to the y minus y to the third over 3 plus 2y. So that means I'm going to take e minus 1/3 plus 2 minus, and all I'm doing there is just plugging in 1, right? E to the first minus 1 to the third over 3 plus 2 times 1. Minus, and now this is e to the -y, right? Oh, no, sorry, e to the -1, e to the -1. Right. Minus -1 to the third over 3. Minus 2. Right. So really, that all simplifies down into e minus 1/3 plus 2 minus e to the -1. This is going to be a negative here, so that's going to cancel out to be a positive, but when I distribute the negative, it's going to go back negative. Minus 1/3. And then plus 2. All said and done, I'm just going to get, looks like when I plugged that in my calculator, forgive me for not doing that, looks like I'm going to get 5.68. Honestly, I'm looking for the decimal anyway. If you wanted to, you could go straight in here and plug this all into your calculator. I think that's what, I don't have this step in my key, so I'm guessing that's what I did. I went this and plugged that all into my calculator and just solved it that way. But I got 5.68. 5.68. 11 and what?
11 and 14.
Number 11. 2.6 repeating. And that's the same thing for 14.
Okay, I was wondering, I'm like.
Yeah, you get the same answer for those two. Coincidence.
I think not.
No, I actually say that. All right, Amanda, what one did you need to do? Number 2.
Well, it sounded like number 2 we have a test.
Number 2?
The one where you had to do the
Oh, use substitution?
Yeah.
I mean, you'll have to do use substitution
So,
because that's section 5.5.
yeah. So that's a yes.
I'm not saying, I can neither confirm nor deny.
Okay.
All right. So we have from 0 to 1, right? From 0 to 1. How do I know that? Well, look at my intersection points. I'm not shaded beyond the left of my y-axis. I'm stopping at my x-axis, x value being 0. And then this is intersecting at 1 comma e. Did they need to tell us that it was going to intersect at 1 comma e? I don't think so. I think we probably could have solved that algebraically by just taking e to the x is equal to x e to the x squared and just solving that. We would have probably gotten that it would be 1, but whatever, it gave us that, so we don't even need to do that work. All right, now we do top minus bottom, e to the x minus, I don't need this parenthesis here, x squared, or sorry, just x, e to the x squared dx. Now, this is, this would be, I don't want to differentiate, or sorry, I don't want to perform the integral on the entire thing. Why? Because that second piece in there has that u substitution going on. So I'm going to break it apart. I'm going to say from 0 to 1 of e to the x minus from 0 to 1 of x e to the x squared. And I forgot my dx's. Now, what does that mean? That means that I can perform the integral here, but because e to the x just e to the x from 0 to 1. And now I'm going to do the u substitution. Okay, I might have to carry this through because this is going to require a little bit more work. Minus, okay, my u value is x squared, so du is 2x dx. So 1/2 du is x dx. Right? Now, 1/2 du goes in for x dx. So here we've got e to the u times 1/2 du. And now let's change our inputs. Now, the nice thing here is that if I'm changing my endpoints, I'm going to plug them into x squared. I'm going to plug them into u here. So I've got 0 going in. Well, 0 squared is 0. Convenient. 1 squared is 1. Very convenient. I don't need to change my endpoints. That's nice. So even if you had forgotten to do that, it still worked out, man. And now let's do the integral. So e to the x, 1 and 0, minus, now this is just 1/2, oops, sorry, not 1e, 1/2 e to the u from 0 to 1. Okay. So this is e minus, now e to the 0 is 1, right? Minus 1/2 e to the first, and I'm going to do this, e to the first minus 1/2 e to the 0, just to kind of show you what I'm doing there. So that's e minus 1 minus 1/2 e minus 1/2. So that gets me a total of e minus 1 minus 1/2 e plus 1/2. So it looks like I've got number 2. Let me just double check my key here. 1/2 e minus 1/2 e is 1/2 e, minus 1/2, I think. Minus 1/2, yeah. And, oops, I forgot my e. 1/2 e minus 1/2, which turns out as a decimal is 0.859. Again, the decimal is fine. I'm just showing algebraically what it works out to with the exact value. If you look up the answer, if you like find it in your book or find it online somewhere, more often than not, this is the only answer that it will give you. But again, I'm okay with the decimal answer. I'm okay with that. Because that just shows me that you're at the correct spot. Questions on that one? Go for it. Jared, go for it. Next one. 18. 18. 18. I'm doing it again. Sorry. Anybody watch Caddyshack today? Is that what I talked about again? Yeah.
What are the 3 movies that
There's a lot of
So
movies
many.
that you get.
Pop or something? Pop.
What?
I know there was one that was like Pop. Nope. Okay, moving on.
Moneyball? That's a
Yeah.
good movie. The Martian is a good movie. You know what's been on recently that I watch every time that it's on now? The Langoliers, that was a good one. That's a made for TV one. Bohemian Rhapsody, the story about Queen.
Yeah, I
That's a
like
good
that one.
movie. That's a good movie. Yeah. The worst movie ever? Is that the one with Sandra Bullock?
I don't know, they just are in space and there's no talking.
Right, and then she just ends up on Earth.
Yeah.
Spoiler alert.
Like, there's
It's like
no
there's
talking.
and it's like 0 probability that that would actually happen.
It's literally just like a camera in a space shuttle. And
Right, that's
there's no talking in the whole 2 hours instead of.
I don't like it. I don't like it. Okay, so this is 18. So just to kind of sketch the graph to see what's going on, this is, what transformation is that? That'd be outside the square root. That'd be
Right one.
the right one. Right one. So here's my first equation. And then x minus y. X minus y. Now, in this case, I think it might be better to do x minus 1 is equal to y. Oh, no, x minus 1, excuse me. X minus y, 1 is equal to y. Okay, that means that I've got slope of 1, y-intercept of negative 1. So, it looks like we've got this little sliver in there. That's what I'm looking for. That's the little piece of shaded region that I'm looking for. Now, I've got to figure out where these are going to cross because this isn't giving me endpoints here. So when it does not give you endpoints, you have to figure out where they cross. Well, the best way to do that is to solve it. What do I mean by that? I mean plug, since I've already got y is equal to x minus 1, I'm going to say, okay, x minus 1 is equal to the square root of x minus 1 and see what x values work. So I square the opposite side, meaning I'm going to have to FOIL this. So x squared minus 2x plus 1 is equal to x minus 1. I subtract the x, add the 1, factor, x equals 2, x equals 1. Which makes sense. Take a look, confirm it in the graph. You see that x equals 1 is an intersection. X equals 2 is an intersection. Right? I'm not saying the actual coordinates here. I'm just saying the x values, where those things happen, are the endpoints here of my shaded region. So from 1 to 2, they cross. So let's find the integral from 1 to 2. Top looks like it's my square root function, the square root of x minus 1. The bottom is the x minus 1. Okay, so there we go. Now the rest is just algebra. Okay, am I going to have to do some U substitution here? Yep, looks like it. So I'm going to break it apart again, just like I did the last one. 1 and 2, the square root of x minus 1. And let's do this. That would have been negative x plus 1. Should I? You know what? I'm not going to do that. That's not a good idea. Because now I'm going to do this from 1 to 2 of just x minus 1. So now we do the u substitution. We plug in u as x minus 1. So du is dx. So that means this is going to be square root of u du. With new endpoints, well, if I plug in 1, I get 1 minus 1 is 0. If I plug in 2, I get 2 minus 1 is 1. So I change my endpoints from 1 to 2 to 0 to 1. Let's do, this just turns into x squared over 2 minus x from 1 to 2. So let's keep that in there. X squared over 2 minus x from 1 to 2. And now let's do the integral here. So this is u to the 1/2, right? So u to the 3/2 over 3/2 from 0 to 1. I'm just going to carry this through because now this is going to turn into, I like to write it now, 2/3 u to the 3/2, 1 and 0, minus x squared over 2, minus x from 1 to 2. Plug in 1, I get 2/3. Plug in 0, I get 0. So really it's just 2/3 minus. Plug in 2, I get 4 over 2, which is 2, minus 2. Okay, is that right?
I did something way confusing.
I did. I combined it now.
Oh, please. Oh, that's right. This is. I'm good. Sorry, I was looking at the wrong piece. I was like, how did I get it 1/2? Duh, it's right here. I plug in 1 and I get 1/2 minus 1. So this is going to be 2/3 minus. That's going to cancel. Okay, this is going to be, what's 1/2 minus 1? Negative 1/2, right? But the negative 1/2 is going to turn positive 1/2. But it's going to be subtracted. So now I got to take 2/3 minus 1/2, which 2/3 minus 1/2 is 1/6, or in other words, 0.16 repeating.
You could just combine the two things once you substitute, if you substitute u back in.
That's true. That's true.
That's what I did.
Yeah, know that if you wanted to take x, what was it? X minus 1, what was it underneath the radical? If you want to put x minus 1 back in, you could just keep the integral of all of the same thing. Keep it 2 to 1 instead of changing the input to 0. That's true. Because that kind of complicates things a little bit, doesn't it?
So
That might be a little simpler way to do it.
So instead of changing the dimension, just plug it back in.
Right.
Give everything.
Right. So you would just plug x minus 1 back in for u and keep your definite integral endpoints. Rather than changing your endpoints and having to do them to 2 different things. I mean, this is like correct u substitution. That's like the way you're supposed to do it. But it ends up being a little simpler if you just keep the endpoints the same and plug x minus 1 back in for u. You get the same answer. What's that? That's what you do.
Do you have to use your substitution? Cutie. But I didn't use it and I got the same thing.
You should. Did you get the 2/3?
Yeah.
curious. If it was here's the thing. If this wasn't, I think just du is equal to dx, I think something would have been off. You know, I think because the derivative of the thing on the inside was just a 1, then I think it would have been okay. That's the reason it's okay that you didn't do it. Be careful with that though. If this had turned out to be like du is equal to 3dx, and then it's 1/3 du, then things would have been a little different. Yeah.
I gotta grab it on the ground.
Sure.
Is there any other ones that have, you have to do?
I don't know offhand. I can't remember. Yeah, really. It's math related, right?
Yep.
Yeah, just print off notes or something.
Yeah.
That's a lie. I'm trying to see if there's any other ones that do U substitution.
I think we should bring back the hat.
Bring back the hat. I'm good. Maybe I should start wearing different hats each day.
Yeah, you should. Wear a party hat for Sydney's birthday.
When's your birthday?
Are you actually serious? You can't be serious.
She's part of every day.
Isn't it like the last day of school?
No, remember. At least we have this conversation every day.
For like every single day.
It's on the 7th.
Wow. It's on his senior picnic. Do I
Oh,
really
that's right.
matter?
I knew that.
really matter.
You
You're
matter.
just a number.
All right.
He's ready to Sydney's birthday.
I won't forget. All right, questions? Yeah, you want the test review?
Yes, please.
We'll do that.
Oh, that's a good grade.
Last homework assignment. And you know, test reviews aren't really even a homework assignment.
They're heavily recommended.
Yeah, recommended. Highly recommended. I already have the key up in the book.
Now I know.
You go.
Hey, I guess there's an exam review.
That was good. That was actually good.
Okay, so again, there's this review. We're going to go over this tomorrow, so you can work the rest of the class today. On this review, we'll go over this tomorrow, answer any questions tomorrow, I'll post the key, and then the test for these 2 sections is on Friday. I got to be honest, it's mostly the quiz. Notice here that the test review, I've only got just a couple of questions, 9 and 10 down there at the bottom. Notice that you do not have to integrate over y for either of those 2 questions. I tried to make them a little simpler versions of the ones you get on homework. But test over this stuff on Friday. On Monday, I just finished making the exam. And then I made the exam review during our testing period. I made the exam and the exam review. So I'll be giving you guys the exam review on Monday. And Monday and Tuesday, as I have it right now, are scheduled just work days on the exam review. We'll go over it Tuesday, Wednesday. You have the senior picnic Friday of next week. And that's also Sydney's birthday. And then on Monday, we'll finish going over anything that we need to. And then again, our exam is here is on that Tuesday and Wednesday. Sound good?
I should have voted for her. You look at yourself. Oh, wow.